Hello guys, welcome to our YouTube channel. I hope you are excited to be here with us. In this video, we'll be using substitution to integrate some functions. So to be specific, we'll be using the variable u. We'll be substituting the variable u in the place of some other functions or components of a function. So the technique of u substitution, you use one of the functions, you choose one of the functions or a component of the function to be u. Here we have two functions, 2x and e to the power of x squared. These are two functions. So we have to decide what we choose to be our u. But then when we're looking at these two functions, we check the properties. We check that this function, e to the power of x squared, is a composite function because of, let's say, the function of ex, of e to the exponent of x. Let's say f of x is e to the power of x, and g of x is x squared. Then h of x is equal to e to the power of x squared. We can see that hx is written in terms of these functions, so it's the same as, is the composite function of f, because of is the same as f is the composite function of x, so it's e to the power of x squared. So when using u substitution, it's very ideal like to first choose the function that is a composite function, the function that is written in terms of the other function, to be our u. So in this case, we see that our composite function is, it's e to the power of x squared, but we can also use its components. Let's say its component is this one, like this is its component. We can choose this one to be our u, but usually you can try both of them to see which one works easier. But like in this video, we'll try both of them to see if they both work or only one works. Let's choose our u to be equal to e to the power to the exponent of x squared. So in the place of e to the exponent, e to the power of x squared, we write u. So now we okay, let me first, okay, it's fine. Then I derive this function du in terms of dx is equivalent to e to the power of x squared multiplied by 2x. But I see that I've seen this 2x somewhere else. So, and this e to the power of x squared is u. So here in the place of this, I can just write u here. I can just write u. So this implies that du is equivalent to u multiplied by 2x times dx. But then I see that in my function I have dx and 2x. So I can see that I can write this in terms of u, because of I have a u and I have a du here. So this implies that du over u is equivalent to 2x dx. So in the place of 2x dx, I'll write du over u. So I write the integration symbol. So this one and this one, they divide. So our function will be left with 1 du. But we know that when we are deriving a function of this form, let's say we are integrating a function of this form, is the same as x n plus 1 or divided by n plus 1 plus constant c. So here 1 is the same as x to the power of 0. So when we integrate this, is the same as x 0 plus 1. 0 plus 1 is what? Is 1. 1 plus 1 is, I'm saying 0 plus 1 is 1 plus c. So this is equivalent to x plus 1. So here, because of this integrand is in terms of u, the solution will be u plus c. But we know that like this function, the original function is in terms of x, so the final answer must be in terms of x. So I go back and see what is u. So in the place of u is this. So that is our solution, e to the power of x squared plus c. That is when we choose our u to be this, to be the composite function itself. But let's say now we choose the component of the composite function, the component of the composite function I'm talking about this. Let's say we choose it. Let's see if it's gonna work, because of for you to understand these things, like you must attempt it in different ways to see if this can work and this can work. That's how you get better at this. Let me write there the function. Our function is 2x multiplied by e to the power of x squared. So this is our integrand, integration symbol in terms of dx. Now we are choosing our u to be equals to x squared. So this implies that du is equivalent to 2x dx. Now we see that we have our 2x and dx. Okay, let me rewrite this in this form, because of in multiplication 1 times 2 is equivalent to 2 times 1. So here I'm going to write e to the power x squared times 2x dx. So in the place of 2x dx, I can just write du. So in the place of x squared, I know I write u. The integration symbol does not change. But we know that like when you integrate a function, an exponential function of this form, it is, when you integrate it, is the same as e to the power of u all divided by plus c. That is our solution. And e and the ln of e is equivalent to 1. So it's the same that when you integrate this function, you just get the exponential function. So whenever you integrate it, you get it, and when you derive it, you get it. This is a steering function. So now it's e to the power of u. So in the place of u, I write x squared is the same as e to the power of x squared plus c. So now let's compare it to our first solution and see if this is the same. You see this one and this one are the same, whether you're using the composite function or its component. But sometimes one of them is simpler to use than the other one. Sometimes the other one, like, it's really difficult to use. So it's very ideal for you to check. The advice that you can use is that, like, when you see x to the power of 2, you can already see that when you derive this, it gives you this. So that can give you a hint on how to choose u. But like every time when you choose u, look at the composite function. It usually works. But I will do more examples so that like we understand this better, because of some examples will open your mind in other ways.